Good morning, everyone. Thank you so much for having me, and thank you for joining this session. I'm really excited to be sharing some of the things that I've learned about working with GraphQL and serverless with all of you. Whoa, this is going to be painful. I'm going to try not to move too much. That's going to be hard. But as Jason mentioned, I highly recommend you follow the Serverless September hashtag on Twitter. You're going to find daily updates on serverless if you're really interested in the topic. But yeah, building scalable APIs using GraphQL and serverless. So as I was building this talk, I selfishly built this talk because I love both GraphQL and serverless, and I was trying to figure out which are some of the things that stand out that these two technologies have in common. And the very first one that I included here is the fact that they're both on the hype train. As we're speaking right now, there's probably someone out there that is publishing an open source library for us to use either with serverless or with GraphQL. If any of you has read the State of JavaScript, the latest one, you're also going to notice that GraphQL is one of the hottest topics, and in only 1 year or 2 years, the usage has grown from 5% to 20% of the users, and more than 60% of the people that have taken the survey are super interested in learning about GraphQL. So it's definitely something that's going to help you in your career as you progress here. And then serverless, as Jason mentioned, we're running serverless days, and if you're going to look at the map of serverless days, you're going to see that starting from 2 years ago until this year, there's a Serverless Days conference that's happening on every single continent out there, with probably multiple conferences happening in the same area. And that's just one indicator of how much interest there is in this area. Another thing that they have in common is that they're both extremely appealing to JavaScript developers. As you've learned this morning from Chris, serverless will help front-end developers to extend their skills into the backend, to extend the applications and the products that they're building to be a lot more powerful without having to learn a lot of the configuration management and without having to learn a lot about infrastructure and managing servers. And it's the same is valid for GraphQL. With GraphQL, front-end developers will be empowered to build features as they go without being blocked by APIs and features already existing on the backend. So we have access to all of the data, and we only get the data that we need with GraphQL, which is great. Funnily enough, they both emerged around the same time. GraphQL specification was open sourced in 2015, and serverless, Lambda in particular, serverless functions have been first released at the end of 2014. And you might think that the fact that they were released around the same time doesn't really mean anything, but I think in technology, we all see that there's certain trends that happen, and it's good to pay attention to that as well. And there's still one thing that connects them. It's very strong. It's also magic. And we're going to spend today figuring out what's this last element that they do have in common. So let's start with GraphQL. What I realized yesterday is that today is Friday the 13th, which is was a spooky moment. This is yeah. So I'm using all the fire animations. So in 2012, when the team at Facebook started building GraphQL, they were actually rewriting their mobile applications. And as they were doing that, they realized that they have a very big task ahead. They need to build a data fetching API powerful enough to describe all of Facebook. And I'll let that sink in. All of Facebook. There is folklore that says that at any given moment, Facebook is probably making hundreds of requests based on a single page that is being shown. And I'm going to show you here the main page, the timeline of my Facebook page, and you're going to see that there's a lot of things happening. So on the left-hand side, you will see links to my Messenger app, links to a list of events, links to groups, lots of data there. On the top bar, you're going to see information about my user. My name is Simona, my profile picture. And then on the right-hand side, you'll see information like people that I might know, birthdays, and event invites. And if we were to think about all the data that's coming here and how we would request that from a REST perspective, then we would probably make a lot of requests that are in this form. So we request data about my user using my ID, and then from there go on to retrieving the list of events that I've been invited to, the list of friends that have been suggested to me, and maybe my friends' birthdays as well. And these are just a couple of requests to give you an idea of what types of requests we might have. And then if we were to look at a single instance of those types of requests, for example, if I'm requesting a list of events, one type of event and the data that I would get in a RESTful API, it would include things like the name of the event, Web Unleashed, the location, Toronto, the organizer, FITC, wonderful FITC. And then I highly recommend you check out my colleague's talk, Jen Looper. She's absolutely amazing. She has a brilliant talk, and she's also the founder of View Vixens. If you haven't heard about that, it's basically a community that helps people coming from underrepresented groups to learn about View. But if we look at the previous page, and then we look at the data that's being requested, we actually see that we only need the number of events in both parts of the page. So we're listing that we're being invited to 4 events. But we actually retrieved a lot more data than we needed. So in this case, our options are either to maintain the existing endpoints, which retrieve all the data, and that would mean that we would be overfetching data, which means that we are retrieving more data than we actually need to display on that page. And the way I think about this, it's going to be very, not visual, but it's going to make you feel guilty. But it's almost like we're stealing money from our users. Because in a country like Canada or in a country like the UK, we don't really care about the amount of data that you use on a daily basis or when you're using an application. But actually in countries where you have to pay a lot of money to get access to internet, every single piece of data that you're sending over the wire, that is going to count towards what that person is paying at the end of the month. So the more we can limit what we're sending over the wire, the better it is. The other option that we might have is, instead of overfetching, we can decide to add a new endpoint. But adding a new endpoint is not only creating that endpoint. We actually have to sit together with the entire team, decide whether this is the right thing to do, what's the data that's being returned. We have to turn that into a task. We have to work with the product teams to prioritize this new feature, and we have to work with the front-end teams to actually use this new endpoint. So it's not just one field or one new endpoint. It is actually an entire process behind adding this new endpoint. Now let's have a look at another example. So we have here the list of people you may know, and one of the suggestions here, this is better. One of the suggestions here is that I become friends with Galnaz. And you can see here that the data that's being displayed is her name, her profile picture, and the number of mutual friends. So from a RESTful perspective, we would make, to display that data, we would make requests to this URL with the friend suggestions, which returns a JSON object, and then we can see an array of mutual friends. So then what we have to do is create a new series of requests that will return every single person that is a mutual friend that we should become friends with. And this is known as underfetching, or actually it's known as the N+1 problem, which you can find not only in RESTful APIs, but also, for example, when making database requests. You need to, that's when you make a request only to find out that you have to make another N request in order to retrieve all the data that you need to display there. So here we have, again, the two options of underfetching or creating a new endpoint. What would be the problem of underfetching? If we have to create new requests, then that means that we're spending time on that round trips to the server to retrieve all that data, and that means that we are spending precious time that the user does not see what we want them to see. And this is, you might ask yourself, why do we care about overfetching and underfetching, even though I kind of hinted at this. But apart from the fact that we are not being conscious of people's data usage, there's also this, documented in the High Performance Browser Networking book, which I highly recommend, from Ilya Gregoric, where he talks about the user perception on performance and how is the user perceiving when we're delaying displaying data. And you can see that from anywhere from 0 to 1 second, the users are engaged. They have the feeling either that the application is instant, there is a small perceptible delay, or the machine is working, everything's fine. But anything after 1 second, initially they will be likely to context switch. So go check their email, go check Twitter, go check Instagram, and anything that's above 10 seconds, it just means that the task is abandoned, and that's not something that we want our users to experience. And this is a quote from the same book where Ilya talks about the fastest network request is a request not made, which is so true, right? So what if we had this magical tool that would allow us to not make that continuous or huge number of requests? And this is, as you might imagine, GraphQL, where basically we create a query that requests the data that we need. So in this case, we retrieve the data about our user by filtering by their ID, and then we retrieve the name, picture, URL, events, and we only retrieve the count of those events, and the list of friend suggestions with the information that we need to define. So on your left-hand side, you will see the data that we are requesting, and then on the right-hand side, you will see the data that is being returned by the server. So and there's there's a mirroring there, and that's on purpose. That's great news, because it means that whatever we're requesting from our API is what the user or the client will actually get. And when we start building APIs using GraphQL, the first step is developing the schema. This is a contract that we are defining where we describe all the operations that will be available for this API, and also the types of all the objects that we are retrieving. And this is very important, because this, as you will see soon, this is actually how we end up documenting our API in real time as well. So I mentioned they're strongly typed, and the way you would create types in GraphQL is by using the type keyword, and then you define the name of the type, which is in this case people, and then all the fields that you want that type to have, ID, name, avatar, and you can see that there's primitive types as well, like ID is a primitive type, string, and URL is a custom type that I've defined. And then we can also nest types, so now we have a type team that includes the last field there is people, which returns an array of objects of type people. And the next things that we need to define is, so we've defined these types that will be returned by our API, but we actually need to define which are the operations that are available on this API as well. And there's two types of operations that you see there. The first one is the query operation, and this is the equivalent of your GET request from the REST API. So this is how you read data from a GraphQL API by creating queries and running queries. And here we're defining that the name of the operation that we're creating is teams, and this is returning a list of an array of teams. And then the other type of operation that we've created here is of type mutation, and this is how you update data. This is how you update, create, or delete data. And in this case, there's a increment points operation that receives an ID as a parameter and returns a team object. We also have a type of subscription which allows you to connect with WebSockets and get real-time information, but it's not part of this example. And that was the contract, that was the schema. But then the next step that we need to do is actually implement how we're going to execute those operations. And this is what's known as resolvers as well. So you see here that I'm implementing the teams and increment points operations. And for both of them, I'm actually not requesting the data from a database. I'm not reading the data from a database in this current application. I'm actually requesting the data from an existing API. And this is a very good example of how you would be using GraphQL, especially if you already have RESTful APIs implemented. You would add GraphQL as a thin layer on top of your existing APIs. And you end up making those calls to your existing endpoints. And then GraphQL will filter out, depending on the query that comes in, will filter out the fields that you don't require in that query. Another cool thing about GraphQL is that it has amazing tooling, and GraphQL is a good example of that. Basically, GraphQL allows you to, let's see if this runs. So in here, you will have access to the list, first of all, to documentation. So you see there's a panel for docs, and that's where you have access to all of the operations that you've defined for your API and all of the types that are being returned for your and fields for your API. And that's very useful. That's your real-time documentation. You don't have to create a Swagger definition anymore. That's going to be described in your schema, and through introspection, GraphQL will return that data there. The other thing that GraphQL can do for us is actually execute queries. So it's almost like a SQL ID or a database client where you query your database, and you can create your query within that client, you execute it, and then once you're happy with how the data that is being returned, then you add that query into your application. It's the same here, only that your data is actually your API. So GraphQL will allow you to execute, to run requests, and then it will it will give you the results. The other cool thing is that it gives us also error checking. So if we're trying to execute a query that doesn't exist or an operation that doesn't exist, it will tell us that this operation doesn't exist. And maybe if there's a good enough similarity between words, it will also give you suggestions in regards to what operation you might actually you intended to use. So with GraphQL, we get very good performance because we eliminate those steps where we get all of the data and we need to parse it out, and we don't have to make a million requests. We only make one request that will retrieve all of the data for us. We also get flexibility in terms of the data that we asked for. We don't get more data nor less data. It is a single round trip that will retrieve all of the data that we've asked for. And then we also have tooling like GraphQL, but there's other tools around that as well that will give you a lot of developer productivity as well. So then the next thing that we're looking at is serverless. And I'll start with a code. The line of code that's the fastest to write, that never breaks, that doesn't need maintenance, is the line of code that you never had to write. This is very much along the same lines of the fastest network request is the one that you didn't do, or the line of code that doesn't have any bugs is no code, right? But basically, with serverless, we are spending less time writing code configuration code. And most of the times when we're writing serverless code, we are actually reusing services. So if you think of serverless, there's two different aspects of it. The first one is serverless functions, and there's also the aspect of managed services. And most of the times, one without the other, they're not as good. So serverless functions are things like Lambda or Azure functions or Cloud functions, where you write tiny snippets of code that will execute based off of an event that's incoming. It can be an HTTP request, it can be a file that has been uploaded on a network drive, or a message that has been posted on a queue that will trigger an execution of this particular snippet of code. And then the other aspect is the managed services. And managed services can be those queues that are triggering the events, but it can also be services like authentication services. So think of Auth0 or Active Directory. Those are services that implement and take care of authentication for us. We don't have to reinvent the wheel there. We don't have to implement those services ourselves. They're being implemented by third-party services or providers, and they scale along with our serverless functions as well. So we write less code by using serverless. And in particular, when it comes to HTTP functions, we look at this from, we have our HTTP code implemented in a function, and then that will turn into an URL that is accessible to our users publicly. And this is what this is our API endpoint. And one of the things that I've mentioned that serverless does is auto scalability. And you can see in this example, in this video that I'm hoping it actually plays. So imagine that this is a this is a metrics dashboard where you can see the number of servers there, which is at the top bar. Now you can see that there's one server online. But then the more requests are coming in, the serverless provider will actually create more instances that are running the code for us, and they will auto-scale without us having to configure any of that. So we don't have to previously understand how many users are going to access our service, and then understand what are the capabilities of our infrastructure, and then provision based off of that. That is something that the serverless provider will take care of for us. So then if we think of GraphQL, where do we add GraphQL into that mix? It's basically right there where we are at the serverless function. We initialize GraphQL there, and every single request will be intercepted there. And in practice, there's two things that we will always need. The first one is the GraphQL endpoint that will it will intercept our requests, and then the graphical UI, which is the client that you've seen earlier, where you can inspect the API definition, where you can execute requests and inspect the results of that. And for the GraphQL endpoint, this is an example of how you would use GraphQL JS. And I'm not sure if that's very visible there, but basically what we do there, we create a serverless function that receives two parameters, a context object and a request object, and then we take in the request body, which is the actual query that we want to execute, and we call GraphQL by passing in the schema definition that we've created, the query that comes from our request body, the resolvers, which remember are the implementation, how we retrieve the data, and then any variables and operation names that we might have, and then we return that as part of the context response object. And the graphical UI is actually a React application that you will find online. I'll add a GitHub URL here soon. But basically what you have to do there is just replace the URL in the fetch function. Instead of, you have to add there the API for your GraphQL, the URL for your GraphQL API. And that's all that you need to do. But with serverless, what we get is reusable APIs. We also get auto-scaling out of the box, and we get easy integration with data sources. I've mentioned there managed services, data sources like databases or queues or file systems. Those are things that the cloud providers normally help with connecting to those data sources. So good integration there. And no servers to manage. So then if we think of GraphQL and serverless, how do they work together and why are they such a good fit? And I start with this square here, or rectangle, and this is our monolithical application or our microservice. And as we started experimenting with serverless, we quickly realized that we can migrate some of the services that we have in our application, things like our cron jobs, or if you have parts of your applications that are processing data from files and then saving them in a database, those are the types of functions that you can easily migrate to serverless, or even sending emails. If you have to send emails on a monthly basis with updates to your users or your customers, serverless is the perfect example of that. You only run it once, it needs to scale, you don't need a server that will host that service for an entire month if you only need it for one day. And as you learn about this and you start becoming more accustomed with serverless, you end up creating more and more functions. And soon you will end up with something like this, where you have tiny functions all over the place, and it's very hard to manage them. And this is where I see GraphQL coming very nicely together with serverless as well, because GraphQL will offer you that documentation for all of your endpoints, and it will give you a single endpoint, a single entry for all of your functions and all of your existing API endpoints. And I'll attempt to do a live demo, although my microphone will not be very... Is this okay? Okay. So let's try that. Is everyone excited about GraphQL and serverless? Yeah? Woohoo! Awesome. So if my internet works perfectly, it works fine. Let's do this. I've created a few demos in the past, so if this doesn't work, we're gonna have a look at something that exists already. And I've just created test 5, right? We have nothing here. I'm gonna increase. Is this better? Oh. We've tried this. Okay. Technical difficulties are the best. Amazing. Okay, so I'm gonna do all of this live coding using VS Code. Let me know if you see this okay. Maybe I should change theme. Okay, never mind. So I have this Azure extension that allows us to create very quickly Azure functions. So I went into the Azure icon there, and in order to create a new function, I have to click this Create New Project, which will ask me to select the folder that will contain my function, and then it will ask me what language do I want to use. So I can use JavaScript, TypeScript, C#, Python, Java, PowerShell. Probably there's other options there, but for us, JavaScript is the best, so that's what we're gonna use. And then it will ask me what type of event do I want to listen to. So in this case, because we're building an API, it will be an HTTP trigger, but you have options for listening to all the other events, types of events that I mentioned earlier. And let's name this GraphQL API. So this will create a function for us, and it will ask me what type of authorization level do I want to use. I'll use anonymous, but it's highly recommended that you use a token for your APIs as well. And what this has done, it has used a template that to generate code for us. So in this case, it's created a GraphQL API folder, and in function.json I have the definition for my function, where we have a list of bindings and in this case, it's only the HTTP binding, the HTTP trigger. This is what we listen to. What's the authentication level? It's a lot of the options that we've selected previously, and also the response here is of type HTTP as well. And in our index.js, we have a simple hello world function where we parse the body of the request. And if we have a name object, then that's what we're going to return. Otherwise, we're going to return an error. But this is not what we care about. We really want to test GraphQL. And to spare you me typing very slowly, I've actually created user snippet. Wait. GraphQL API. And this is a very new computer. That's why I have no stickers and not a lot installed. All right, so this is all of the code that we need in order to create an HTTP, an API endpoint that uses GraphQL. So it's 45 lines of code. And the first thing that you will see here is that we are requiring GraphQL, and I'll go ahead and actually install it. So I'll run npm install GraphQL, and then we also see that we need Axios. So we're requiring all of these Axios and GraphQL, and then we are defining the schema, which in this case we've already seen the team type, we've seen the query that we had earlier, and the mutation increment points, and then these are our resolvers, again code that we've seen in the past, and the function that actually executes our GraphQL request. So now if I want to run this, everything should work as expected. I'm going to go in VS Code, I'm going to click Run. And ideally, what this will do, it will start the Azure Functions runtime that will listen to HTTP requests, and it will create an endpoint, and a URL for us to call into. So I have Postman here, and I'm not sure if you know, but they have a GraphQL feature here where we can send GraphQL queries into that. I'm hoping that the speaker that speaks from Postman will talk about this as well later today. But we have here the local host's URL GraphQL API, and as you can see, I'm sending a post request, and as part of our body, I'm sending this mutation query that filters based off of ID, and then it returns the name and the points for each team. So if I'm running this, what it should happen is it should call into our function. We can see here the logs for that. I could also add a breakpoint here to inspect maybe the data that comes in. The thing that you're seeing here is the concept of cold start. Does everyone know what a cold start is? Yeah? If you're an optimist, that's called a warm-up time as well, if you want to look at that. But basically, these two URLs that you see here are actually other two functions, and it takes time for, if I haven't used that API in a while, it takes time for the framework to take the code, install dependencies, and create a new instance that will run that code for us. So that's the cold start. And I've recently learned that there's a similar concept in machine learning as well, where cold start, it refers to the time it takes for a product to acquire all of the data that is needed so that models and the models are actually useful. Piece of knowledge there. So here what we can see that we've executed a mutation, and we've returned exactly the data that we've asked for. So now if I add ID here as well, it will break here because I've added a breakpoint, and we can inspect even what are the types of data that we've sent in, run this, and then we'll get back an incremented value for our points. And then if I want to run a query, the query that we had here was teams, and I want to return name, points, ID, and that should work as well. So we can see here that in our database, or in our APIs, we have two teams, the red and green teams, and we return points and ID as well. So I hope this makes sense. We didn't use the graphical interface because we've just created the endpoint, the bare bones endpoint. For us to actually use the graphical interface as well, what we would need is a place where we could deploy a React application. Normally that would be in a static storage like S3 or Azure Blob static storage, and we deploy that React application, and we can inspect that data there. I've done this separately in a previous example, so you can see here. I'm going to refresh this page just to make sure that everything works accordingly. And I wanted to show here the docs where you can inspect the queries, and you can inspect the types here that are defined for each query, for example, a team, and all the fields here. And I've actually created, to make things easier for all of you, I've created an npm package called create graphless that will generate all the resources, all the initial resources that you need to create a GraphQL endpoint and the graphical interface. And it will also create all the resources, the actual infrastructure that you need in Azure in order to run the website and to run the serverless function. So it's still in beta. But if you have any feedback on this tool, or if you have any anything that you'd like to add, it's open for contributions. Please submit them. So now that we've seen, in this case, how we can create a GraphQL endpoint that calls into two existing APIs that we've created in the past, and those two are reading data from our database. Another type of usage for GraphQL would be when we actually can call existing APIs, or we can read from a database directly from our GraphQL endpoint, or even we could read from a cache so that we cache some of that data. We don't always hit the database. These are all types of use cases or ways in which you could use and read data for your API. And GraphQL is actually fantastic when you have multiple clients with different data needs. That's when GraphQL thrives, when you're building your application. So remember when we talked about why Facebook has created GraphQL, it was because they had a web client, and when they wanted to implement the mobile client, they realized that they want to display data in different ways, which meant that they needed to create new endpoints for their API, for their data to be returned in different forms. And GraphQL helps you with that. So if we look at them side by side, serverless will help us with easy integration of data sources. The serverless provider will make sure to provide that. And GraphQL will abstract away the data sources. So remember in those animations, we've seen that we can replace API endpoints with databases, with caches, but our endpoint remains exactly the same. So we have that easy abstraction of data sources. With serverless, we get auto scalability. The provider will create as many instances as needed for us, whereas with GraphQL, we get a single endpoint, a single entry endpoint for our APIs. With serverless, we write less code. We reuse what has been written by other providers. And then with GraphQL, we make a smaller number of requests. We make a single request whenever needed. So what both of these have in common, which is the magic, is developer productivity. And they allow us to achieve more by doing less. This icon here is actually one of the mascots of Serverless Days. I've created here a series of resources that might help you get to learn more about serverless using Azure Functions, but also the last link there is a workshop that I ran in the past that gets you started with this application that I've created live here. And then there's a link to the Create Graphless NPM package as well. So thank you so much for your time, and I hope this was super useful. Please reach out if you have any questions. I'll be around today and tomorrow at the Microsoft booth, and then I'm always online on Twitter, LinkedIn, and all the other social platforms. Thank you.